You know how the temperature on your weather app never seems to tell the whole story? You see a number, but it just doesn't match how you actually feel outside. So what's the missing piece of the puzzle? Well, it's something invisible. It's all around us, and it completely changes how we experience heat. Let's dive in and figure this out.
Right? Think about it. It's the exact same temperature, but two totally different worlds. One is that dry, almost pleasant kind of heat. The other? It's that heavy, sticky, I need another shower kind of miserable. That huge difference is exactly what we're going to get to the bottom of.
The secret to that miserable, sticky feeling, it's hiding in plain sight. It's in something we can't see, but boy, can we feel it. It's time to take a closer look at the hidden ingredients of the very air we're breathing. And that hidden ingredient is water. Yep, the air isn't just, air. It's a mix of different gases, and a super important part of that mix is water vapor. And the amount of this invisible water in the air is what makes all the difference in the world. Okay, so to really crack this case, we need to learn a bit of the language. There are a few key terms that the pros use to measure and talk about the air, and these are going to be our essential clues for solving this whole comfort mystery. All right, first up, there are actually two different kinds of temperature. Dry bulb, that's the one we all know. It's the number on the news, the reading on a standard thermometer. But wet bulb temperature, this is where it gets interesting. Imagine wrapping a wet cloth around the end of a thermometer. As the water evaporates, it cools the bulb down. The bigger the temperature drop between the dry and wet readings, the drier the air is, because more evaporation is happening. If there's barely any difference, well, that means the air is already jam-packed with moisture. Now this brings us to a really important difference: absolute versus relative humidity. Let's think of it like this. Imagine the air is a sponge. Absolute humidity is the actual weight of the water soaked into that sponge. Simple enough. Relative humidity, the one we hear about all the time, tells us how full that sponge is as a percentage. And here's the kicker. A warm sponge is bigger and can hold way more water than a cold sponge. So 50% relative humidity on a hot day means there is a lot more actual water in the air than 50% on a cold day. This quote from the source material just nails it. Relative humidity is all about the degree of saturation, not the actual amount of water. So when you hear it's 40% humidity, that just means the air is 40% full for whatever its current temperature is. And our final clue is the dew point. This is the tipping point. It's the exact temperature where our air sponge becomes totally full, it hits 100% relative humidity and just can't hold another drop of water vapor. If the air gets any colder than that, the vapor is forced to turn back into liquid. That's dew on the grass or the fog on your bathroom mirror after a hot shower. So, we've got all these clues, right? Dry bulb, wet bulb, humidity, dew point. But how in the world do they all fit together? Well, let me introduce you to the hero of our story, the one tool that makes sense of everything. And here it is, the psychrometric chart. I know, it looks like something from a rocket science textbook, but stick with me. This isn't just some crazy graph. It's basically a map. It's the master key that connects everything we just learned about the air. Let's just do a quick tour of this map. Along the bottom, that's our good old dry bulb temperature. Over on the right, that's the absolute humidity, the real water content. See those big sweeping curves? Those are lines of relative humidity. And the diagonal lines cutting across, that's our wet bulb temperature. Everything we just talked about is right here. Now here's the magic. This is the really cool part. This chart is a decoder ring. If you know just two things about the air, say the temperature and the relative humidity, you can find that exact spot on this map and instantly know all the other properties. It's amazing. All right, enough theory. We've got our map, so let's actually use it. We're going to become air detectives for a minute and solve a very common mystery that probably happens in your own home. So here's the case. Picture this. Your room is a comfortable 25 degrees Celsius with 40% relative humidity, but outside it's chilly, and the inside of your window pane is only 8 degrees. So the big question is, are those windows going to fog up? Our chart has the answer. Okay, detectives, let's solve this. First, find 25 degrees Celsius on the bottom axis. Got it? Now travel straight up until you hit that big curved line for 40% relative humidity. You are here. Now, from that exact point, just slide your fingers straight to the left until you bump into the edge, the 100% saturation curve. Now look down at the temperature there, and you'll see it's right around 10 degrees Celsius. That, my friends, is our dew point. And just like that, mystery solved. The window at 8 degrees is colder than the air's dew point of 10 degrees. So any of that room air that touches the chilly window gets cooled below its saturation point. And poof, the water vapor has nowhere to go but to turn back into liquid. That's your foggy window. Case closed.
Now, this isn't just for solving foggy window puzzles, which is cool in itself. This chart is absolutely fundamental to how we design the buildings we live and work in every single day. If we zoom in on the chart, you'll find this little shaded area right here, and it's labeled the comfort zone. This is so important because it shows us that comfort isn't just a single temperature, it's the perfect combination of both temperature and humidity.
According to the data, that sweet spot is somewhere between 22 and 27 degrees Celsius and between 40 and 60% relative humidity. If it gets too dry, our skin and sinuses feel it. If it gets too humid, our bodies can't cool off by sweating. That little box is the goal.
And that right there is the entire job of our heating and air conditioning systems. HVAC isn't just about making air hot or cold, and it's constantly working to move the air's properties around on this chart, adding or removing heat, adding or removing moisture, all to land us right inside that comfort zone.
So, we started with a simple question about why 85 degrees can feel so different, and we ended up here with this incredible tool. You now have the key to understanding the invisible atmosphere all around you. You can read the map of the air. So, how will you see the world differently now?